Okay, to wrap up our predator-prey lesson here, need to finish talking about some forms of defenses. So we went through a lot of different coloration defenses by prey species, but we have some other categories too. One being like group behavior responses, and a lot of times that's with herd species. The musk oxen is a really good example of this. When they feel threatened, they'll form this protective barrier circle around their young where they'll all face out, and it's quite difficult for a predator to break that circle and get at the young more um, easy prey of the young species. The young of the species. Then we have mechanical defenses like the porcupines. Porcupines are rather slow animals, so they can't use speed. They have very poor eyesight, but they do have a good sense of smell and good hearing protection. And so when a predator species gets near, they can shake and throw quills into that predator species, and the quills then have little barbs on them that expand once they get into the skin of the predator, and it's really difficult for predators to remove these quills. So quite often, especially if these quills are thrown in the face of a predator, it really could result in the death of that predator. So that's a mechanical defense of the porcupine. There aren't many species that can deal with that. Porcupine can be very devastating on young tree species because they'll girdle trees by chewing the bark. And so sometimes land managers will try and increase the fisher population because fishers are adept at killing porcupines. Now, fishers are the largest member or the largest weasel. They're in the weasel family. They're probably third largest compared to wolverines, badgers, and then fishers. They're about the size of a large house cat. Another form of defense might be posturing in order to warn of a chemical poison. And we've all are familiar with skunks and them raising their tail to say, hey, don't come near me. Now this is their coloration here is another aposematic example of coloration, but the way they'll stand with their tail up pointed at you gives you an indication that they're going to spray, and you have one last chance to get out. And this is just a few examples of defense, right? We have others like different sounds, different smells, different behaviors. There's a lot of different defense that prey species have to avoid predation. Escape techniques, heightened senses, use of topography, color, or cover, all of these are really important. And if we didn't have them, then we'd probably have systems that are out of balance. You see a squirrel jumping from tree to tree here to avoid the pine marten. You see the pronghorn in the wide open spaces that can outrun just about anything. And the mule deer blending in, hiding behind rocks, making it really difficult for the predators to find them. So if it's not always these boom and bust cycles between predators and prey, what is it? And I like the example of the Yellowstone grizzly. We're in about our 60th year probably of really studying wholeheartedly the Yellowstone grizzly, and we've learned a lot. And one is that they do shift their diet, and there's a lot of things that affect the grizzly. For example, they're highly dependent upon cutthroat trout in the streams during spawning, and with the introduction of lake trout to Lake Yellowstone, the cutthroat trout population has significantly declined, and they're not going up the streams to spawn. And so without that high energy food source late in the summer, which is really important for bears before they go into hibernation or torpor, they have to find another food to eat, and we've seen their predation increase on elk as a result of the introduced fish species. We've also seen some shifts in their behavior with the reintroduction of wolves into the area as the elk populations have gone down in some areas. So like I said, studying the predator-prey relationships can be really difficult but very fascinating, and there's always probably more at play than initially meets the eye. Okay, so we need to understand a few terms here: keystone, apex, and obligate predation. And you can, keystone species, apex and obligate predators. So let's talk about keystone species first. They maintain diversity in a community, and wolves are a classic example of a keystone species because they eat their prey that then cannot eat so many plant species, and we've seen and heard that example in Yellowstone many times over, and we'll have some other readings for you to take a look at that this semester. There's a lot of other species that could be considered keystone species. This was first kind of originally described by someone studying starfish off of the Pacific coast, and they found that starfish were the main predator in some of the bays, and when they removed starfish from the ecosystem, the diversity got cut in half because starfish were eating the acorn barnacle, and when they were removed, the barnacle and mussels began to kind of fill every available space, which outcompeted a lot of the other species in the area. So you had your species diversity drop dramatically. So that's a good example of a keystone predator. Wolves are another example. You can have a keystone species like the prairie dog because so many other members of a prairie ecosystem are dependent upon them for food or the habitat that they create. We could also call them ecosystem engineers because they're designing the ecosystem for a lot of other species. The apex predator is a predator that only has a few if any, species that it itself is the prey for. So things like polar bears, wolves, wolverines, they're all apex predators. They're at the very top of the food chain. And then the obligate predator we've discussed, like the black-footed ferret is obligate on prairie dog, or the lynx is obligate on the snowshoe hare. Typically, if you're an obligate predator, you are also a specialist. And that concludes our discussion on predator-prey relationships. There's a lot more to learn, so make sure that you complete the assignment in its entirety.